All right, this is AP Calculus AB, Unit 3, Lesson 2, Using Properties of Limits. You may recall last time we talked about average speed versus instantaneous speed. So let's say we take this scenario. The displacement, or the distance an object falls, is expressed by the equation 16t squared, right? And that's for the acceleration of gravity being 32 feet per second per second. That means at the end of 1 second, the object is falling 32 feet per second. At the end of 2 seconds, it's falling 64 feet per second, and so on and so forth. Okay, so the 16 is half of 32. That's where that comes from. Okay, and we're interested in answering this question. What is the instantaneous speed at 2 seconds? The instantaneous speed at 2 seconds. Now, speed is rate of change. It's change in y over change in x, or change in displacement over change in time. Okay, so we can define it as change in displacement over change in time, or we can call it displacement final minus displacement initial over time final minus time initial, right? It's just, I'm kind of making up my variables as I go. But the way it worked out was this. We took the displacement at 2 seconds. So the object is falling, right? The object is falling. And we take the displacement at 2 seconds and a little bit more, right? So here's 2 plus h. And we take the displacement at both of those times. Displacement at 2, displacement at 2 plus h. Okay? And we find the slope between those two bars, right? So the displacement at 2 plus h is going to be 6, let's call it displacement at 2 plus h, minus the displacement at 2, just all divided by the change in time, 2 plus h, minus 2. Okay, and we can substitute or simplify 16t squared, 2 plus h squared, minus 16 times 2 squared, divided by 2's cancel, leaving just h, right? And we basically play this little mental game. It says, what if h is really tiny, right? What if h is really tiny and we get super, super close to the value 2, right? So we're finding this, the slope between 2 points that are very, very, very close together. That's the idea of a limit, okay? The limit. So the displacement, or the speed at 2 seconds is equal to the limit, and here's the notation, LIM for limit, as h approaches 0 of 16 times 2 plus h squared minus 16 times 2 squared over h. Okay? And so this idea of a limit as something approaches something is very important. So let's analyze that on our calculator. So I'm going to pull up Desmos. I'm going to pull up Desmos, not Desleast, Desmos. All right. Why are mathematicians always late? Because they calculate later, dude. Not calculate sooner. All right. So here we go. Let's do a table. I'm going to enter a table. You can do this on your TI-84 calculator too, your graphing calculator. Then use the table feature. Enter a formula. To enter a formula in Desmos, I'm going to use x1 as my variable, not h. 16, 2 plus x1 squared minus 16 x1 squared all over x1. Okay. All right, and we're going to put in some values. We're interested in what's happening in and around 2, right? So what is that? What if h is a little bit bigger than 2? What if h is a little bit bigger? The limit as h goes to 0, as x goes to 0 in this case. All right, so I'm going to try 0.1, right? 0.1. And let's make sure I entered that. Oh, I see what I did. This is not x1, this is 2. There we go. There we go, because that answer wasn't making sense. All right, 0.1, 0.01. We're going to let h get smaller and smaller and smaller, constantly getting smaller, 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 smaller. And what is happening to our output values? Okay, I need another 0 here. You may notice that they're getting closer and closer and closer to 64, right? And that's what we call the limit as h approaches 0 from the right-hand side. Now, I want to check this. I want to check it both sides. I want to check it from the left-hand side as well. So let's try letting it be negative 0.1 and let it get closer to 0 from the negative side. Negative 0.01, negative 0.001. Okay, and negative 0.0001. And again, what's happening to my output values? What are they approaching? They seem to be approaching the same number, 64. Okay, and so here's what I've discovered by experimentation with my table. I've discovered this. I've discovered the limit as h approaches 0 from the right side of S of 2 equals the limit as h approaches 0 from the left side of S of 2 equals 64. They both equal 64 from the left-hand side and the right-hand side. And so I'm introducing something here. This is called the right-hand limit. Right-hand limit. What happens as x approaches the limit from the right-hand side? And this is known as the left-hand limit. Left-hand limit. And what happens as we approach the value from the left-hand side, from below the number? From above the number for the right hand, from below the number for the left hand, continuously getting closer and closer and closer. Okay? That's called a two-sided limit. All right? And so here's the definition. The limit as x approaches c of f equals L if and only if, so this flows both ways, if and only if, this is true both ways. The limit as x approaches c from the left of f equals the limit as x approaches c from the right of f equals L. And notice something that is not part of this definition. It does not require that we plug in C for F and get out L. That is not a requirement. There could be that value could be undefined, and we're going to get into that in the next lesson when we deal with going off to infinity and dividing by 0 and all those kinds of things. Does not require the function value at that point to be L. It could be something completely different. We're interested in limits are all about what happens as the x value approaches the limit value, but not as the x value equals the limit value. And that's really a fine but important distinction. Okay. Now there are some special rules here about this that are important to keep in mind. Some ways that we can break things down. So for example, if I want to find the limit as x approaches 2 of x squared plus 2, okay, first of all I ask myself, is this a continuous function? All right, continuous, by continuous I mean, can it be drawn without picking up my pencil? Right? If it's continuous and there are no gaps and no holes in it, then we can simply find it by direct substitution. The limit as x approaches 2 of x squared plus 2 is 2 squared plus 2, or 4 plus 2, or 6, right? As x approaches 2, the function value approaches 6, okay? But what about this? What about the limit as x approaches 2 of x plus 2 times x minus 3 over x plus 2, okay? Now you might be tempted to think, well, the x plus 2's cancel, but what happens with as x equal, actually, I should say x minus 2, x minus 2. What happens as x equals 2 to this function? As x equals 2 to this function. You plug in 2 and you get 0, right? 0, and you get 2 minus 3 is negative 1, divided by 0, which is undefined. But the limit is not undefined. The limit actually does exist. And we can do that by canceling out the x minus 2, and you're going to get to some of this here. Canceling out the x minus 2, and we can say this is the same as the limit as x approaches 2 of x minus 3. Okay? Provided that x does not equal 2. Right? We can't cancel out x minus 2 unless we put in the caveat that x cannot equal 2. But remember, for limits, we don't care what the function value is at 2, just what it does above and below. And so lo and behold, we get 2 minus 3, or negative 1. Now let's look at that function here. Let's look at that function in Desmos. Okay, and let's do x minus 2, x minus 3, all over x minus 2. Okay, and look at what happens at 2. If I get my cursor right at 2, notice right at 2 there's a hole there on the graph. It's undefined, right? And I'm realizing that's my head is covering that up here. Okay, that is undefined at 2. So right there, it's undefined. There's a hole there. Okay, there's a hole, but the function value as I approach from the right is negative 0.7, negative 0.74, negative 0.8, negative 0.82. It's approaching a number. It's approaching that negative 1 value, right? And as I approach from the left-hand side of 2, I get outputs of negative 1.36, 1.33, 1.25, and so on. And it's approaching negative 1 as well. It approaches negative 1 from the left and the right. Therefore, by the definition of the limits, it exists, and it is negative 1. Okay? The limit as x approaches 2 from the right equals negative 1, and the limit as x approaches 2 from the left equals negative 1. Therefore, and this flows both directions, the limit as x approaches 2 from both directions is negative 1. Okay. All right, so hopefully that makes sense. I'm not going to go into more detail. Your lesson is, but feel free to ask any questions and book a live lesson if you need help.